Okay, let's try that again. Okay, so you're using their laws of exponents. The only difference is today you're going to use decimals and fractions. So what it's going to force you to do is start to remember how to convert a decimal into a fraction or a fraction into a decimal. Okay, and then you work with them in that sense. So let's look at the examples on page 70. First example on page 70 is 7 to the 1/2 times 7 to the 3rd. Okay. So what does our laws of exponents say we do with these exponents right here? Add them. That's right. So I get 7 to the 1/2 plus 3. Okay? So how do I add 3 and 1/2? Go ahead.
You change 3 to like an improper fraction.
3, okay. So what is it?
It'd be 3 over 7.
No?
3
over 1 right
one.
now.
Okay. Yeah.
And now what's your common denominator?
Common denominator is
What's common denominator between 2 and 1?
it's
Does anybody want to help him? What is it? 2. It's 2, right? So I need to times the bottom by 2 to get to that, right? Whatever I do to the bottom, I have to do to the top. So it's 7, 1/2 plus 6 over 2. Right? Does that still give me 3 when I take 6 divided by 2? Yeah, sure. So that's 7 to the 7 over 2. All right, so far? Now, here's something that we want to see, though. Okay? If I were asking you, and we're not there yet, but we are going to get there, so I want to do it now. Again, it's one of those things I like to introduce to you, so that when we see it the next time, it's not so fresh. Okay? This is 7 over 2. The fraction part of it creates our root. So this can actually be written as the square root of 7 to the power of 7. Okay? Because this would be like the second root, or the square root. Okay? So that is something that we'll look at going to at some point. But that's it. I'm not going to do any more with that guy. Okay? I'm going to leave it as is. Okay? This is fine right here with what they've asked. They said put it into one single expression. That's fine. In a couple days' time, that's better. All right? But for today, this is all we need to be able to do. Okay? So that's the first one on page 70. The second one on page 70. 9, 1.25 over 9 to the 3/4 equals. All right, so now I have a decimal and a fraction. So now you have to decide what would you prefer to work with. You prefer to work with decimals or you prefer to work with fractions? Okay, so any preference?
Fractions.
Fractions? Sure. Okay, so then what do we need to do with this top one then?
Make it into a fraction.
Make it into a fraction. What is 1.25 as a fraction?
5 over 4.
Okay, let's start with, before you go to the improper, what is it? What is it? 1 1/4. So 1 1/4, right? Which makes it, as Marshall said, 5 over 4. What do I do with the exponents when I have quotient or division?
Add them with the common denominator.
I'm going to add these exponents together.
Subtract them.
Which one is it, Casey?
Subtract.
Subtract. So it's 9, 5 over 4 minus 3 over 4 equals. What does that equal?
9 2 over 4.
9 and 2 over 4, which is
1/2.
9 to the 1/2. What's 9 to the 1/2 equal?
4.5.
For me?
4.5.
4.5? We agree?
Yes.
Jesse, you're shaking your head? What do you think it is?
3.
Yes. You're right. Okay? What does this mean? Again, I just did it on the last page. It means square root, right? So I want the square root of 9. which is 3. Marshall, I'm not taking 9 and dividing it by 2. I'm taking 9 to the exponent of 1/2, which means in this case square root. So square root of 9 is 3. Okay? The next one. Three to the 0.25 over 3 to the 3/4, all to the power of 3. Okay? Actually, sorry, before I go on, let's go back to this guy. All right? I said Casey wanted to do this in terms of fractions, so that's fine. I much prefer that. But I am going to show those of you that are more comfortable with decimals what happens here. So I've got 9, 1.25, right? Over 9 to the 0.75. So when I subtract those, 1.25 subtract 0.75 is 0.5. Okay, and again, we're encouraging you not to use your calculator. This can be done on your calculator. 9 exponent 0.5 would have given you the correct answer. But at this point, I am going to want to change it to this. Okay? So this will get you so far, and that's okay. But I'm going to eventually want to get it to the fraction and then done. All right? So now, let's change this guy up here. Okay? So let's change it to a fraction. So that's 3 1/4, right? Over 3 3/4 to the third. Now you have a choice right now. At this point, you can multiply this by 3 and this by 3, the exponents. That's okay. Myself, I probably work inside the brackets and simplify it before I multiply it in. So again, it's another scenario where I have two choices to make. Both are okay, whatever you're more comfortable with. So I'm going to be biased and do it my way. So I got 3 1/4 minus 3/4 to the third. Okay? What is 1/4 subtract 3/4?
-2/4.
Negative 2 over 4. So that's 3 to the negative 1/2, agreed? Still to the exponent 3. Okay, so far? What do I do with an exponent to the exponent?
Add,
Pardon me?
add them.
What did I do here, Casey?
Added them.
Am I doing the same thing?
Yes.
This is an exponent to an exponent?
No.
No, it's not. Right? This is an exponent to another exponent. So what do I do with them?
Multiply.
Multiply them. This times this equals 3 negative 3 over 2. How do I make that positive?
Put it over 1.
1 over 3 to the 3 over 2. Right? You're done there. You're done there. Also okay. Again, because the 2 is down here, it's a square root. 3 to the third. Okay, again, no need for this yet. Just get me to here. Get me to here. All right? Any questions about that? None? Everyone's okay? Okay. Let's look at the last one then. 27 over 8. To negative 4 over 10. So I made the switch. I changed that 0.4 to 4 over 10. Okay? This one's unique because both of these could be rewritten. All right? If I break 27 down to its smallest parts with an exponent, what is 27? Excellent, Justice. It's 3 cubed, right? What about 8?
2 cubed.
2 cubed? Beautiful. Great work. Minus 4 over 10 equals. So what I have then is I have 3 over 2 to the third to the negative 4 over 10. Excuse me. Thank you. So I don't need to do this. Okay? It's not necessary. But I wanted to show you what it looks like. What I should do next is multiply this and multiply that. Okay? So I get 2. This times this is negative 12 over 10. Sorry, this should be a 3 up top here. And down here I have 2, negative 12 over 10. Okay? Can I reduce negative 12 over 10? Yeah? What can I reduce it to?
Negative 6 over 5.
Okay, so I've got 3, negative 6 over 5, 2, negative 6 over 5. How do I make this? How do I make that right there have positive exponents?
Switch the side down.
What's that called? When it comes to fractions. Pardon me? Invert? Close. Okay. When I flip the top with the bottom, what's that called?
Inverse.
No. That's what she said. Okay. It's called reciprocate. Right? Reciprocate it. Make it its reciprocal. So that means I've taken the top, moved it to the bottom to the top. So here's what I get. 2, 6 over 5 over 3, 6 over 5. Done. If I wanted to rewrite this, just to make it, I could rewrite it like this. 5th root, 2 to the 6th over 3 to the 6th. Again, it's the 5th root because I have the 1/5 here. All right? That's it, that's all, folks. Okay? Looks confusing. And it causes grief. This is not a section that gets done well. A lot of it has to do with fractions. Nobody likes fractions. Okay? So that's part of it. Part of it is you just need to know your rules. You need to know those rules. So you got to work with them. Okay? Let's do some questions from yesterday, if you have any. Anybody have questions from work yesterday? So that's 4-1 or 4-2.
3,
Page, please.
67.
Where do you want to start?
Any of them. Just confusing.
No, it's a calculator question. Okay? So, simplify then evaluate. All right. 1.4 to the negative 3. How do I make it a positive?
Flip it. Reciprocate.
Reciprocate it. 1.4 cubed. What is, so now you use your calculator. 1 divided by 1.4 cubed. And you have to do it to 4 decimal places. Go ahead, Justice. Go ahead.
3644.
There's your solution.
Okay. Calculator.
Yes. I myself am going to try and eliminate the calculator as much as I can. But it's easier said than done. Okay? But it may make it easier as well. Let's look at B. Okay, so if I just focus on inside the brackets right now. All right? What is 4 squared? What's 2 cubed? Right? So far? How do I make that a positive exponent? Reciprocate it. What's the solution? Without using your calculator, Marshall. What's negative 2 times negative 2?
Positive.
Times negative 2? Didn't need a calculator, did I? Okay? Negative 2 times negative 2 times negative 2 is negative 8. Fair enough? Somebody asked me this yesterday. Let's look at C. Okay, so I have 2 to the negative 2 times 2 to the 4. What do I do with the exponents? Add them. What's negative 2 plus 4? Positive 2. So I have that, right? Which is 2 to the negative 4 equals 1 over 2 to the 4th, which is 1 over 16. Again, another question I don't really need a calculator for. And I would leave these as fractions. Yes, I know it asks you to 4 decimal places, if necessary. It's not necessary. If I leave it as a fraction, I'm done. That's as precise as I can get. Okay, the moment I have to divide it, then I'm rounding numbers off, which I don't want to do. Okay? You good now? Okay. Other questions from 4.1 or 4.2?
Or F on page 67.
Okay. I like this question. All right, Jane, what do I do with the exponents inside the brackets?
Add them.
Okay, let's look on page 66. Which rule are you going to use?
Okay.
Quotient. So what do I do with the exponents?
You don't use switch them.
Okay, so you're looking at the quotients of powers, right?
Yeah.
So I have a to the m over a to the n. And what's the next step? A to the
And I don't know.
We'll look at the quotient of powers. You see the quotient of powers on there, right? Second from the top in that chart.
Oh, yeah.
Okay, so what am I doing with the exponents?
Here's
I am subtracting them. So if I subtract these exponents, what am I going to end up with?
negative. Oh, negative 3 to negative 5.
Right.
That's negative 8.
Very good work. You're right. Now what do I do with my exponents?
Oh, isn't that answer?
Not yet.
Then you multiply.
And I multiply them. That's the third rule on there, right? Okay. There's my answer. Okay. The chart on page 66 is repeated on page 70. Do you suppose there's some significance for that chart? They showed it to you twice? Yeah. So make sure you have it beside you when you're doing these questions. Okay? There's a reason that they're giving it to you twice. They're saying like, look, you gotta know this. This is how I do it. So make sure you're looking at the chart when you're doing these questions. It will make things easier until you remember what the rules are. Fair enough? Okay? Any other questions? Okay.